We talk about the future like it's already decided. Self-driving cars, smart homes, AI assistants that know your next move, and always, electric vehicles. The story we've been told is clean and linear. The age of combustion is ending and a quieter, greener future is just around the corner. But there's a part of that story no one talks about. Out beyond the highways, far from the charging stations and city grids, there are machines so massive, so essential, that switching them off, even for a second, isn't an option. Cargo ships longer than skyscrapers are still burning oil by the ton. Passenger jets lift hundreds into the air on wings powered by century-old fuel. These are the arteries of our civilization, invisible, uncelebrated, unstoppable. And they're next. Not because they're ready, not because the technology is perfect, but because the pressure is real, and the clock is moving faster than anyone imagined. Behind closed doors, engineers are rewriting the laws of propulsion. Startups are making impossible claims. And governments are placing billion-dollar bets on systems that haven't yet proven they can survive the real world. This isn't about hype, it's about desperation. Because no one knows what happens if these giants don't change, and no one is ready for what it will cost if they do. This is the part of the electric revolution no one prepared for. And it begins where the land ends, in the air and on open water. Stick with us, because by the end of this film, you'll understand how the quiet revolution in the sky and sea could reshape everything, from geopolitics to your grocery bill. We like to think the worst of it is behind us. That emissions are dropping, that solar, wind, and electric cars are enough. But there's a quiet math that doesn't make the headlines, because it's not happening on land. The truth is, just 15 cargo ships, 15, emit more sulfur pollution than every car on the planet combined. And air travel? At the current pace, aviation emissions are on track to triple by 2050. Triple. These aren't fringe figures. They're the engine room of the global economy, the $8 trillion supply chain, the 120,000 daily flights that knit the world together, the floating cities that carry our food, fuel, clothes, everything, across thousands of miles of open water. And every one of them runs on ancient toxic fuel. For years, we ignored it. Because what else could we do? Jet engines aren't like car motors. Cargo ships don't recharge in a driveway. These machines are too big, too heavy, too far-reaching, or at least, that's what we told ourselves. But the pressure is building. Governments are tightening regulations. Europe has already mandated net zero shipping by 2050. California's ports are phasing out diesel entirely. The International Civil Aviation Organization has issued sweeping carbon caps, and global fuel prices are rising. Fast. Now, for the first time in modern history, the giants are being forced to adapt. Boeing is investing in electric aircraft research. Airbus is building hydrogen flight demonstrators. Rolls-Royce, the titan of jet propulsion, is testing battery electric engines. Shipping giant Maersk is betting billions on methanol and electrified short-haul routes. Even Tesla Energy has hinted at maritime battery applications. And then there are the outliers. Startups like Aviation, designing fully electric commuter planes from scratch. Candela, developing boats that glide above the water using AI-controlled hydrofoils. But here's the catch. Every engineer, every executive, every scientist in this race is facing the same brutal equation. Electric power works great on land, where the weight is supported by asphalt. In the air and at sea, every kilogram counts, and there's no room for failure. So how do you replace engines that were designed to operate under extreme pressure, friction, and distance, with batteries that weigh 4 times more than the fuel they replace? No one has a definitive answer, but everyone's being forced to try. Because this is no longer a question of innovation, it's one of necessity. The machines that carried us into the modern world are the same ones pulling us toward collapse, and if they don't evolve, they'll take everything with them. We think of electric transport as a modern miracle, the product of 21st century urgency. But what if this wasn't new? What if we had the answers over a century ago? In 1882, a silent vessel drifted down the Thames. No smoke, no noise, no sails. It was the first electric boat designed by British engineer Anthony Reckenzon. Powered by primitive batteries, it stunned onlookers, not because it worked, but because it worked without fire. And then, it was forgotten. Not because it failed, but because oil was cheaper. more explosive, easier to control. Electric propulsion lost the race, not on performance, but on profit. Then in the 1970s, as gas shortages rocked the US, NASA quietly began experimenting with electric jet propulsion. But again, the timing was wrong. The world wasn't ready to trade fire for silence. Fast forward to the 2000s. When the world laughed at the idea of battery-powered performance, one company made it their mission. Tesla, from 2009 to 2017, took what was niche and turned it into a movement. In less than a decade, electric cars went from toys for hobbyists to a new standard. But here's the paradox. As we electrified the highways, the skies and seas were left behind. Because electrifying cars is one thing, electrifying a 400-ton aircraft at 35,000 feet is another. And yet, the clock is ticking. The European Union has mandated the end of combustion car sales by 2035. Norway is already phasing out fossil-fueled ferries. The International Maritime Organization has set a hard deadline: net zero emissions by 2050. These aren't ideas, they're laws. And they're coming fast. But there's a problem. Battery innovation isn't keeping up. Today's lithium-ion cells can barely power a long-range drone, let alone a container ship. Solid-state batteries, lithium-sulfur chemistry, and hydrogen fuel cells are promising, but in labs, not oceans. So we have the pressure. We have the deadlines. What we don't have, yet, is a solution that scales. That's the timeline we're up against. A race between regulation and reality. Between what we need to happen and what physics will allow. And if the timeline breaks, if we don't figure this out in time, then no amount of ambition will keep the world moving. Change doesn't come all at once. It starts with silence, a whisper that becomes a tremor, until one day, the ground shifts beneath us. In 2021, a small ferry in Norway did the unthinkable. It ran a full year on electric power. No diesel, no fumes, no maintenance shutdowns. And it worked. Better than anyone expected. Operational costs dropped by 82%. 82, one vessel, 1 year. And suddenly, every shipping executive in the world had a new question. What if we could scale this? Then came a story no one saw coming. The US military began quietly experimenting with electric naval vessels. Not for sustainability, but for stealth. Because when you're trying to evade radar or sonar, silence isn't optional, it's survival. And internal combustion? It's loud, it's hot, it's detectable. Electric drive, on the other hand, is invisible. Suddenly the Pentagon wasn't asking if it could work, but how soon it could be deployed. Then, in 2023, a test flight in California rewrote the rules of aviation. A hydrogen-electric hybrid aircraft completed a 90-minute flight and cut emissions by over 90% compared to its fossil-fueled counterpart. No black smoke, no sonic trail, just a quiet, ghost-like ascent. And yet, behind the triumphs, something darker was unfolding. One of the most promising startups in the sector, known for a radical battery design, went bankrupt without warning. Investors pulled out, employees scattered, and their patents, quietly acquired by a Chinese aerospace firm just weeks later. In a single move, intellectual property once protected by Western defense interests shifted hands, and with it, the balance of power. Because in this race, the one who controls electric propulsion doesn't just win transport, they win logistics, surveillance, defense, geopolitical leverage. The ocean used to separate us. Now it's the front line, and whoever masters how to cross it, silently, sustainably, securely, wins the future. It's easy to forget how fast the future moves until it arrives in silence. No headlines, no press releases, just a whisper of electrons replacing the roar of combustion. Across hangars, shipyards, and data centers, the front lines of the electric revolution are no longer theoretical. They're industrial, they're global, and they're happening now. Inside a sealed lab in Japan, engineers hold a wafer-thin lithium-sulfur cell the size of a note card, lighter than anything before, capable of storing twice the energy per gram compared to lithium-ion, still unstable, still experimental, but real. Meanwhile, in Sweden, a test boat cuts across the Baltic Sea, not through it, but above it. Riding on AI-controlled hydrofoils, it uses 80% less energy than traditional hulls. There is no wake, no drag, only lift. And inside the control center of a startup outside London, algorithms are doing something no human can. mapping the most efficient flight and shipping routes down to the millisecond using AI-powered route optimization. Weather, cargo weight, battery health, solar exposure, thousands of variables, recalculated every second. This is the power of artificial intelligence when paired with electric mobility. Not just clean, not just quiet, smarter. On one screen, a diesel container ship plows through ocean currents, burning fuel by the metric ton. On another, its prototype counterpart, silent, electric, unmanned, glides with precision. Zero emissions, remote operated, built not to fight the sea, but to work with it. And in the air, jet fuel still dominates, but the cracks are forming. Range maps tell the truth. An Airbus A350 burns 36,000 gallons of jet fuel on a long-haul flight. A battery-powered equivalent, today, could only fly 1/10 that distance. But with next-gen solid-state chemistry, that range doubles, then triples. And as demand surges, something unexpected begins to unfold. Patent wars, investment battles, national subsidies, governments pour billions into clean aviation tech. China announces its first all-electric regional jet. The US triples funding for DARPA propulsion programs. The EU backs airframe startups through accelerated pre-orders. Meanwhile, legacy companies stall. Too big to pivot, too slow to fail. Their assets become dead weight, their stock slides. But the newcomers, the crowd-funded startups with sleek designs and viral backing, explode. Because today's audience doesn't wait for permission. They pre-order the future. And whether it's a hydrofoil boat in Stockholm, a drone taxi in Dubai, or an electric vertical lift cargo aircraft landing on a barge in the Pacific, the age of fire is ending. And in its place, the quiet machines are rising. Progress isn't a straight line, it's a negotiation between what we want and what we're willing to pay to get there. If electric propulsion wins, cargo ships go silent. Flight becomes automated, hyper-efficient, and shockingly quiet. A new global system of trade and travel, clean and continuous, powered by the hum of electrons. Emissions drop, cities breathe, oceans heal. But that's the fantasy. Here's the other version. It fails. The tech doesn't scale fast enough. Battery breakthroughs stall. Early adopters lose faith, and into that vacuum rushes something far more dangerous than carbon greenwashing. Suddenly, every jet engine is hybrid. Every cargo vessel is eco-friendly. The words change, but the smoke stays the same. Worse, desperation breeds shortcuts. Governments, chasing climate goals on a deadline, rush untested electric systems into the skies. A failure, a crash, a blackout at sea. The backlash is immediate. The dream? Delayed another generation. And behind it all, another threat rises. Minerals, cobalt, lithium, nickel, rare earths. The raw ingredients of electric propulsion aren't evenly distributed. They're concentrated in fragile, geopolitically unstable regions. Africa, South America, Central Asia. The price of progress becomes conflict. Trade wars ignite not over oil, but over batteries. And just like that, the promise of a cleaner world becomes a battleground. It's not just a tech race, it's a power shift. From oil giants to battery kings, from combustion to computation, and the consequences are coming. Because while we debate, the climate waits for no one. Let's rewind. A decade ago, a young engineer stood in front of a prototype electric plane. Reporters laughed, aerospace execs scoffed, and she smiled. People laughed at electric planes, she said, but they laughed at electric cars too. She wasn't wrong. And she isn't alone, because around the world there are thousands like her. Pilots, programmers, shipbuilders, students, building machines the world says are impossible, but now, they're taking off. The age of oil defined the 20th century, but it will not define the 21st. The most powerful machines in human history, the ones that shaped empires, moved armies, built civilization, are changing, not with a bang, not with fire, but with silence. The sky, the sea, the rules of the game. The electric revolution was never about cars, it was about everything else. And now, we're on the edge, not of a new vehicle, of a new reality. Because when the world's largest ships and fastest planes go electric, the planet doesn't just breathe easier, it changes direction. And whether we're ready or not, it's already happening. This is just the beginning. What do you think? Will the skies and seas ever go fully electric? Subscribe if you're watching the future happen in real time. Comment below, plane, boat, or both. Which will go electric first?